Imagine there's just one tiny drop of red syrup sitting on the ground. To us, it might look like nothing more than a little bit of something sweet. But to an ant, this could be a very important discovery. At first, only 1 or 2 ants come closer. They don't rush in. They slowly move around the syrup, touching it with their antennae, almost as if they're trying to figure out exactly what they've found. And this is where things get really interesting. Ants don't rely on their eyes the way we do. Their antennae are incredibly sensitive. They use them to detect chemical signals, food, other ants, and even tiny changes in their surroundings. So, when an ant discovers something rich in sugar, it knows it has found a valuable source of energy. For ants, sugar isn't just something sweet. It's fuel. They need energy to move, search for food, carry things, protect the colony, and keep everything running. And that's why sweet substances can be extremely attractive to many species of ants. But here's the fascinating part. How do the other ants know that food has been found? They aren't shouting. They aren't calling each other. And yet, after a while, more and more ants begin to appear. The secret is chemical communication. When an ant finds a good source of food, it can leave behind a chemical trail called a pheromone. Other ants can detect that trail and follow it. And when more ants find the same food, the trail can become stronger. That's why something that started with just 1 or 2 ants can quickly turn into a whole crowd. It's almost like they're using a secret communication system that we can't see. And what we're watching here isn't simply a group of ants eating. We're actually seeing a highly organized social system at work. Some ants search for food. Others collect it. Some carry it back toward the nest. And the food can eventually be shared with other members of the colony. What's even more surprising is that there isn't always a single leader telling them what to do. No ant is standing above the others, giving instructions. Instead, this incredible organization comes from thousands of simple interactions between individual ants. Scientists often describe this kind of behavior as collective intelligence. One ant may seem incredibly simple. But when thousands of ants work together, something much more complex begins to emerge. Now take another look at this syrup. The ants are gathering around it from different directions. They use their mouths to collect the sweet liquid. But here's another fascinating fact that many people don't know. Ants can temporarily store liquid food inside a special part of their digestive system called the crop. Think of it almost like a tiny storage tank. But for an entire colony, that little drop can become a valuable source of energy. There is another challenge to syrup is not like solid food. It's liquid, sticky, and sometimes difficult to handle, so the ants have to adjust the way they move around it. Watch how some of them carefully approach the edges, searching for the easiest way to collect the sweet liquid without getting trapped. Their movements may look random at first, but they're constantly responding to their environment. And as more ants arrive, the activity around the food becomes more intense. What's truly amazing is that ants don't need a large brain to create this kind of organization. Individually, each ant follows relatively simple rules. Search, detect, follow, collect, return. But when thousands of ants follow those simple behaviors at the same time, a remarkably complex system emerges. That's the beauty of the ant colony. It can behave almost like one giant living organism, even though it's made up of thousands of individual ants. So the next time you see ants gathering around something sweet, don't think of it as just a bunch of insects looking for food. You're actually watching a sophisticated survival system. There's chemical communication happening. There's energy management. There's cooperation. There's food sharing. And there's collective intelligence. All happening on a tiny scale right in front of you. A single drop of syrup may seem insignificant to us, but in the world of ants, it can mean something much bigger. It can mean energy. It can mean food for the colony, and it can mean another opportunity to survive. And perhaps that's one of the most beautiful lessons we can learn from these tiny creatures. Sometimes the smallest things hide the most fascinating worlds, and behind every tiny step of an ant, there may be a story of communication, cooperation, and survival that we simply don't notice. But there's still another question. What happens after the ants discover a reliable source of food? The answer reveals just how well organized an ant colony really is. Once a food source has been discovered, the ants don't simply keep eating until nothing is left. Their behavior can change depending on how valuable the food is, how easy it is to reach, and how much of it is still available. This is one of the reasons ant colonies are so fascinating to scientists. They are constantly making decisions without actually having a central brain controlling the entire colony. Each ant reacts to what it senses around itself, and somehow all of those tiny decisions come together. The result is an organized system that can adapt to changing conditions. Look closely at the ants around the syrup. Some remain near the food. Others move away and return again. Some appear to be following the same paths over and over. These repeated routes are not accidental. Once a useful trail has been established, other ants can follow it. And the more successful the trail becomes, the more attractive it can be to other workers. This simple system allows the colony to find efficient routes between the nest and a food source. In fact, this behavior has inspired researchers and engineers. Ant colonies have been studied to understand how simple creatures can solve complicated problems, such as finding efficient paths through a large environment. And here's something even more surprising. Ants don't always choose the shortest path immediately. Instead, they can explore different routes. Some ants may wander farther away. Others may discover a better way. Over time, successful routes receive more attention. Less useful routes gradually become less important. It's almost as if the colony is learning without any single ant actually being taught. This is sometimes called swarm intelligence, and it isn't unique to ants. Similar principles can be found in bees, termites, birds, fish, and many other social animals. Simple individuals working together can create surprisingly intelligent behavior. Now, look at the syrup itself. The bright red syrup may catch our eye, but ants see the world through chemicals. With their antennae, they read invisible trails finding food, danger, and each other. When one ant discovers sweetness, it doesn't just eat, it signals, shares, and sets off a chain reaction. Others follow, collect, and bring it back to the colony. No single ant is in charge, yet together they form a perfectly coordinated system built from thousands of tiny decisions. In their world, there are no words or instructions, only cooperation, communication, and survival emerging from something as small as a single drop of syrup.